But then like I have to that's how I work.
Hey everyone, it's 9:30, so I'm going to start the lecture. Okay. So as you probably saw on Canvas, I updated your grades and added all the extra credits. Some of you are exceeding 100, so I couldn't add anything else to you. There are like 5 of you that probably just see every grade is like complete and I didn't have it. So I hold on to your extra credit points and then I'll add that to your final and your next exam and quiz or homework. And the other thing that I want to mention is that I did that because some of your friends know last semester I was just doing that last minute and the students were worried, what is my grade? They couldn't see it on BBLearn. So I wanted you to feel good that you're doing well and as long as you study, you succeed and all that. But you have 370 points left as of right now. So if you see a C, don't think that, okay, I'm good, I passed the class and I have a C, easily that can change. And I'm here and give you extra credits, do all my best to help you. So keep coming to the class, keep doing extra credits because you may need that, okay? And the other thing is that I have all of your extra credit and makeup exams if you did that. So I have a pile and I stapled everything together and it took me 1 hour yesterday to do that. I thought it just takes like, I don't know, 20 minutes or whatever. So I have them separately. If you had makeup exam, I put it on one pile. So after the class you can pick them up. The other one is people who didn't do makeup exam 2, just the extra credits. And it's in reverse alphabetical order. So it starts from Z to A. And yeah, I guess I can just, I don't know, have like 3 piles or whatever, but I think, you can manage to take them after the class. And if you have class right after this, I put them in my office and I bring them to the class on Wednesday too, so you have the opportunity to take them. And when you're taking them, make sure that you take your own, right? So if you accidentally take, your friend's extra credit, just like return it to me so I can give those to them, because it just takes for me forever if I hand it in the class, okay? So that's that, and I'm also going to have extra office hours as usual. Since I have like this class and my other class 101, I have to have designated times for each. So what I'm going to do, I'm going to just ask you guys, do you prefer 4 to 5:30 or 5:30 to 7 p.m.? Which one?
5:30 to 7.
Okay, how many of you prefer 5:30 to 7? Okay, how many 4 to 5:30? Okay, so what I'm going to do is that since most of you prefer 5 to 6:30, I'm going to be at my office for sure. 5 to 6:30 on Wednesday and Thursday before our exam. But, I'm going to assign 4 to, did I do that right? 4 to 5:30, 5:30 to 7, right? Did I write that? 4 to 5:30. So here, 5:30 to 7 for our class, CHEM275. But I'll be at my office from 4. So if you have like a quick question and you want to ask me, just feel free to stop by, if the other students show up, I'm sure they won't mind. And I talk with them. And so if you can come at like 4, but if you cannot come at like this time, just let me know. And as always, you can just welcome to, email me. I schedule a time to meet with you one-on-one basis, and some of you already did. And if you cannot come in the evenings, I know some of you prefer in the mornings. I still have my office hours after our class today and Wednesday and Friday. And also, if you want me, just email me. I'll make sure that I'll be at my office if you prefer morning times. Does that make sense? Any questions? Good. And I'm going to give your tutor, Sean, some sample questions to solve for you, to prepare you for your exam. And I'm going to post your final quiz today as well. And the reason the deadline is this Friday, because I didn't want for you guys to have any exam next week, because that's no week exam, right? So that's the reason. But yeah, if you're fine, I can also extend the deadline for that till Sunday, if you prefer that. Do you prefer that? For your next quiz, the deadline instead of Friday being Sunday?
Yeah, that's fine.
Okay, so I'm going to put the deadline on Sunday, but I highly encourage you to take it before your exam, because it's open book, open notes, right? You can be prepared potentially for your exam as well. The last thing I'm going to say before I start the lecture, and hopefully that is the last thing on my mind. As you saw, I'm just lecturing really slowly, making sure that everyone that they're struggling with the course, they're catching up. So I'm going to finish this PowerPoint lecture that I have, and depending on our speed, whether or not I can accomplish that today. And next session, I'm going to go through all your homeworks, quizzes, all that, to prepare you for your exam. And next week on Monday, I'm going to have like a broader lecture in a sense of anything that we learn, kind of see the applications in life, So it would be like more practical for you all. So I'm not going to start another topic, new topic. So some of them might be new topic, but you know what I mean. It's just like more practical, so applications in life. And on Wednesday, again, I'm going to solve problems, prepare you for your final. Any questions about that? Yes.
Final, is it during the same, what time is it?
I posted that on, so it's not quite the same, but I posted that on course syllabus and schedule. And in the next class, I'm going to also announce it again. Great question. Yeah. Make sure to know the final. Sometimes, I had this problem last semester too. Sometimes the time or location exactly doesn't match to our usual class time. So make sure to look at the course syllabus to see what time it is and then where it is. But I'm going to announce that in the next class too. Great question. Any other questions? Good. Okay.
What time is the study session? Is it tonight?
Yes. So yes, great question. So Monday, which is basically today, and I think next week it would also be, and it's like 4 to 8. And as I told you, any hour of tutoring that you have, whether with myself or your tutor, I'm going to add 5 points to your 1,000 point in this course. So it will be 0.5 out of 100 final grade. And the only thing that I didn't add is those tutoring that you didn't have with me, but with the tutor. That I'm going to add. I try to enter your grades early on Vandal So if you have questions or concerns, or you don't see it change, but you think you should have seen, you can communicate that with me so I exchange it. So you don't have to worry about it. And if some of you and my other students, few people cannot take the exam on the final day, if that's the case, you're welcome to take it earlier. That's not an issue for me, but I cannot have it later after the exam. But if, you're thinking that you're gonna go out of town or you have other obligations, I don't recommend it, because based on my experience, when students take the exam early, they don't do as well. But, things happen in life. So if you want to take it earlier, that's fine with me. Any questions? Okay. I think I talked about everything that I wanted to talk about. Okay, ethers. Can anyone tell me what was an ether? So how do we know that the compound is ether, is not like mercaptan, or it's not like alcohol?
They have 2 organic groups connected to.
Exactly, this is, and I wrote it in the worst location possible, but you get the idea. Okay, so one thing that I was noticing while grading this extra credit assignment is that sometimes the students do well when it's multiple choice question, whether it's just like by chance or like, they see the structure, they can choose the correct one. But when you want to write it yourself, most of you struggled. And I think that's one of the reasons the students are not doing well, in my class, especially my other class, because, I mean, the main reason is that they don't study. But the second reason is that they rely on multiple choice question style. And then I had some students last semester that we had like so many, and we have on 101 so many numerical questions. And then they give me the answers when their exam is done, and it's like blank. And I'm like, did you answer all the questions in your head? Wow, I'm so impressed, you know. At first I was thinking that they just do everything in their head, and then I realized, no, they're not solving any questions. They just choose the answers randomly, and that's why they weren't doing it. So this is another thing that I realized, that when you want to solve a question yourself, it's more difficult, and maybe it's unfair towards you that I had multiple choice question, but it won't be fair towards me to grade so many papers after each session. Anyway, long story short, I encourage you to, you know, when you're solving problems, first of all, for your final exam and your next exam, go through examples of the book and also the problems that you see, because you may see really similar questions in exam, and try to solve it yourself and see what the issue is, okay? And then contact me, ask me, because grading your last extra credit assignment, as I said, you know, I add the grades to your points so you feel good and all that, but that was concerning to me because the average was like 6 out of 12. So if that would be the case on your exam, you will be having problems. So and I wrote the answers last night so I could save time on our class today, but I'm going to explain these things to you. So when we say, this is one typical question that you're going to see in your exam, right? Give the name of this compound or IUPAC name. So I encourage you to write the expanded structural formula. If you're comfortable and then you can see the name and all that, you don't have to do it. But me, myself, write the expanded structural formula to see what's going on. So you have CH3 attached to CH, right? So you know that, you know, what is the valence of carbon? 4. We should have 4 bonds, right? It already has 1 bond with this hydrogen, and you're welcome to write it as this, right? Or write it as this. So whichever you're more comfortable. So now you have 2 bonds with 2 CH3s and the other bond with CH2. Okay, and I already posted the PowerPoint slides last night, so you don't have to worry about writing things down too, but you're welcome to do that. Anyway, CH2, and then here we have oxygen that is attached to 2 other groups, right? So here we can call that R prime, here R. So what is this compound? It has an oxygen. What category? Ether, right? So this oxygen tells you that you have an ether. And here you have CH2, CH3, right? So when you write these expanded structural formula, it helps you to name it. So one thing to remember, and I saw that in some of your papers, and again, you know, this is the good thing about me grading, you know, your answers, because I see what are you struggling with, right? With the multiple choice question, I cannot exactly see what is the issue. So this was one of the issues, you know. So when you have this oxygen attached to an alkyl, we call that alkoxy. Some of you call that methyl or methoxyl or other names. So this would be alkoxy. So we have methoxy, ethoxy, propoxy, phenoxy, and all that, okay? So remember, the other thing is that, so here, this oxygen that is attached to C2H5. So what is C2H5 itself? Is ethyl, right? When it attaches to oxygen, what would that be? Ethoxy, right? And now, we took care of that part. And now here, do you remember, you know, so the rules that we had before still applies, that you look for the longest chain and you name the carbons. And where you start to name the carbons? From left to right or right to left? Right to left, right? Closer to this oxygen. So we call it 1, 2, 3, and So now, if this is your main chain, what is your substituents? Or what are your substituents? Methyl and ethoxy, right? And when you want to write it, you write ethoxy first because alphabetical order, right? E, M. And what is the carbon number that ethoxy is attached to? 1, right? What is the carbon number that methyl is attached to? And what is the name of this compound? Propane. We have 3 carbon in the main chain. Any question about that? Good? Okay. And was this one? 1-ethoxy, 2-methyl propane. So it depends on how you look at the compound. You can look at it as this part is isobutyl, this part is ethyl, and then you have like ether. Or you can look at it as this is your main compound, propane, and you have methyl and ethoxy attached to it.
Which one is preferred?
I mean, depend on which one you prefer.
Okay. So it doesn't really matter which one we see first, it's just whether we read it correctly?
Yeah, both of
That
them are
makes
correct.
sense.
Yeah. Okay. Any questions? Good. And now let's look at it the other way. So these butyl, sec-butyl, isobutyl, and tert-butyl, I mentioned a lot during the semester in like chapter 2 and then 3 sessions ago when we were talking about naming different compounds. So I expect you to know these well. Can anyone tell me how can you memorize this? Butyl, sec-butyl, isobutyl, and tertiary, tert-butyl. How can you remember which one is which? Do you just rely on your memory? And then, so, imagine you're sitting in the exam and you forgot which one is which. So, yes.
So butyl is just like we did butane, but with the loss of a hydrogen, and then sec-butyl is moving where you attach that to the second carbon, which
Okay.
is why it's sec.
Okay.
And then I still struggle a little bit with iso and tert.
Okay. Great. I mean, great that you know the
Yes.
first part of the answer. And great in the sense that I can see what the issue is. So, you can think of it this way. I'm just choosing. This software updated, and now when I want to do the hand feature, it's just kind of like tricky. Okay. So, do you remember, can anyone tell me what was the difference between N, normal butane, and isobutane? What was the difference?
There's no branch in butane, and there's a branch in isobutane.
Exactly. Normal butane is just like this. But for isobutane, you have a branch. Okay. So butyl, and you know that alkyl in general is generated from alkane when we lose a hydrogen, right? So here, if you eliminate a hydrogen from N-butane, you have 2 different possibilities, and depending on which hydrogen you eliminate, you get butyl and sec-butyl. Okay? But if you eliminate hydrogen from isobutane, you get isobutyl and tert-butyl, depending on which hydrogen you eliminate. Does that make sense? Good? And here we call that tertiary because this carbon was attached to 3 different groups, right? Okay, so if we're good with that,
Wait. I'm not good with that. Your isobutane, your branch is coming off the second, so how is that not sec-butyl? It looks very similar.
so sec-butyl we call that sec-butyl when it's originated from normal butane, N-butane, right? So if you have here your structure CH3, CH2, CH2, CH3. So if you eliminate one of these hydrogens here, you get butyl. If you eliminate one of these middle hydrogens here, you get sec-butyl, because this carbon is attached to two other carbons here.
So it doesn't necessarily have to be on the second carbon, it could be on the third as well.
So you consider, the hydrogen that you dropped, right? You consider the carbon that is attached or was attached to that one, and then see how many carbons it attaches to. Okay? So that would be sec-butyl, and then here in this structure you have like CH3, 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 CH. So if you eliminate this hydrogen that was by itself, and this was the thing that I asked you in the extra credit one, right? Third butyl. And then here, if you eliminate another one of these hydrogens, right? You get like CH2 here, any of this. You get like isobutyl. And just, does that make sense? So I didn't write the whole elimination process, just like letting you know which one was which. Okay, and I included this slide of basically the screenshot of your book in like previous lectures. I think it was like 3 lectures ago. So make sure to go back and study those if you have any difficulty, or ask me. So now, when you see this structure here, what is this one? Can you see why that is isobutyl? So if this is isobutyl, right, you have your CH attached to CH2, 2 CH3. You have your CH here attached to 2 CH3s, 1 CH2. Okay, and since it is branched, it's isobutyl. Good? And then here, what is this one? This one should be easier now that we talked about this. Exactly, C2H5. This is ethyl. So you can name this compound also ethyl isobutyl ether. And you should know both namings. Question? Good?
So what would the other name for this be?
The other. Okay, now let's talk about this compound. Again, it depends on how you look at this compound. You may look at it as like benzene ring, that something is attached to it, or here, like this part of the molecule, right? CH2, CH2, CH3, that it has this part attached to it. Can anyone remember what was this name? Phenyl. Sorry, I meant this part. Sorry. So what is this part? Yes, that is phenyl. Okay. So, and this is something that this difference between phenyl and benzyl, specifically benzyl, among all of you that gave me the extra credit, I think 8 of you, distinguished benzyl and could write the structure. And I also wrote it in your paper that you're the first person that got it right. So make sure to know the difference between phenyl and benzyl. So when you have a benzene ring and you eliminate one hydrogen here, that would be phenyl. Okay, and you should know the formula too. But as long as you know the structure, you can just put carbons and hydrogens around it and then see how many. So basically, benzene, that we eliminated one hydrogen. Remember that we said it's similar to alkyls in a sense, right? And then here, if you have like your benzene ring attached to CH2, we call that, and that attaches to something else, we call that benzyl group. Okay? So remember the difference. Questions? Good? And as I just mentioned, just in the previous slide, if you have like OR, right, or like oxygen that is attached to another group, we call that alkoxy. Now, knowing that here, considering this part and this part, right? So if you have a methyl group that is attached to oxygen, we call that methoxy. Now, if you have a phenyl group that is attached to oxygen, what would that be? Phenoxy. Exactly. Okay? So, now, if I consider this being my main chain, right, and I start naming the carbons, should I go left to right or right to left? Why? Exactly, my oxygen is here. I start, to name from left to right. So, the name of the compound would be, first of all, the base name is propane, right? We have 3 carbons. And then the carbon number 1 is attached to phenoxy. So it would be 1-phenoxy propane. Any question about that? Uh-huh.
The propane at the end of the name, since it's missing a hydrogen, would we still name it propane even though there's CH2, CH2, CH3?
Yes, so this is basically what we did before too, right? If you had like this and then you have like 1 chlorine here, so technically if you count the number of hydrogens, right, it would be 1 less than it should have been, right? So this is how we named them. Yeah. Great question. Any other questions? Good. Okay. Now let's look at it the other way, right? So C3H8. What is this? Propane, exactly. So if I eliminate a hydrogen, what is C3? Propyl, right? And in this case, because you have 3 carbons and this carbon here basically is attached to 2 different things. So here, what do we call this one? Or let me highlight with this. What is this? Phenyl. What is this? We said that the compounds that have like oxygen. Exactly. Ether. And here we have propyl. So the other way to name this compound is to just say phenyl, propyl, ether. And we write these 2 alphabetically.
Why wouldn't you put ether first?
Some books do that, so it's not like the biggest deal. Yeah, when you look at like the structures of these compounds or like naming, you see like 20 different names, all different combinations. So technically it's not wrong. But your book, as a rule of thumb, it just like puts like alcohol at the end or like ether at the end. But if you put it like the other order, it won't be wrong.
On the previous slide.
Okay. So now let's look at it this way. If you want to name this compound as benzene, right? So if this is a benzene, we have something attached to it. So CH2, CH2, CH3, which is like, what is this part? CH2, CH2, CH3. Propyl, right? That is attached to an oxygen. So now what would that be? Exactly. And because this carbon is attached to the rest of the molecule, we call that 1-propoxybenzene. Basically indicating that this carbon is attached to, because technically you can have the second carbon attached to oxygen and benzene, right? So this is kind of like to denote kind of like the different isomers that of butyl, that we have sec-butyl, tert-butyl, so we distinguish them by naming, saying which one is this. So that's why here we also put 1 propoxy benzene to say that this propyl that we have here, this carbon is attached to oxygen, and that oxygen is attached to a benzene ring. Good? Questions? Okay, so this one was also giving some of you a hard time, and this is my drawing ability to have like the 3D structure that you saw before, write it down in the paper. And if I give you something like that, it would be straightforward, so you can distinguish, see the structure and all the atoms well. Okay, so here your book also distinguished this oxygen here by having it as red. That's why I also wrote it here as red. So you have this oxygen that is attached to CH2, and then that CH2 is attached to CH3, right? And then here you count 1, 2, 3, 4, 5, 6, and these are all united together, right? So that's why you have a ring. When you want to write it on paper, you count the number of carbons, and these are all attached to each other, so you realize that you have a ring. But all the bonds are single, so what type of compound would that be? If you have single bonds, 6 carbons attached with each other to each other. Exactly, cyclohexane, right? And then here you have 2 hydrogens here, 2 here, 2 here, 2 here, 2 here, right? So I put them all here. And here, this carbon that I here write as green is attached to one CH3 here. So now basically you want to write the name of this compound. Are you all comfortable switching from 3D to 2D? Good. So anything that you see, you just put on the paper. I remember we had one course in our undergrad, which they would give us 3D structures, and then we had to write it 2D, and it was for people who wanted to study civil engineering and all that. So it was one of the most difficult courses that I had. But this one should be straightforward. Anyway, so now if we're good having 3D to 2D, let's talk about branches and all that. So you already told me that this compound would be cyclohexane. Okay, and in the exam what I give you, I say cyclohexene, benzene, right, phenyl. So make sure that if you have only single bonds, that is cyclohexane. And here, what is this one? Now, are we comfortable? What is the name of this branch here? Ethoxy, right? Because you have C2H5, which is ethyl that is attached to this oxygen. And then what is this one? CH3 methyl, right? And in this case, because you have two, so if you had only one branch, whether CH3 or ethoxy, it didn't matter where you put it, right? But here, because you have two branches, we should specify what is the number of the carbon number. And then in this case, you just put one here and then can go this way or that way, doesn't matter. But we call that 1 ethoxy, 1 methyl. And as I said, the reason that we put this 1 is that you can have also this, CH3 here instead of here. So in that case, your compound would be 1 ethoxy, 3 methyl. Does that make sense? Good? Is that clear why I put 1 ethoxy, 1 methyl cyclohexane? Yes?
This is a little bit nitpicky, but do you need the dash in between the methyl and cyclohexane, or does it really not matter?
So it doesn't really matter. So your book doesn't put it, but I never give you something that the difference between two answers would be a dash or a comma. So don't worry about it. So, any other questions? Good. Now let's talk about the other way. So this structure, most of you got it right. So it was really interesting to me that all of you knew dicyclopropyl ether. But some of you had the structure like this, for instance. Just two triangles attached to oxygen. So remember, you should have, so in each of these points, we have a carbon. So you should attach your oxygen to a carbon. But regardless, this structure, I think, was straightforward. So when we say di, we have two, right? So so what is this? Cyclopropane, exactly. And now, so this is CH2, 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 okay? And when we eliminate one hydrogen, we put like here, denoting that now this is CH, right? That is attached to something else. Or like we just put it like that. So that's why this part here, this is cyclopropyl. So this would be like cyclopropyl. And then ether is like oxygen, which has two bonds. And now when you want to attach this, you have like two of that, right, which is attached to an ether. And as I said, I think these structures most of you are comfortable with, right? Any questions? Okay, now, so this structure is the one that I was talking about that maybe 8 people got it right. So make sure you know it for your exam and also your final exam. So this is benzyl. So you should have CH2 here and then attach it to the rest of your molecule. So if you don't have that, if you only have this, what would this be? What is this? Phenyl, exactly. But benzyl has also this CH2 here. And ether, you know that it's like oxygen that has like 2 bonds, and di means 2. And so if you want to attach this, right, so you have 2 of that and attach it to ether, this is the structure that makes sense, right? You have like di-benzyl, and then you have ether that attaches these 2 benzyl groups. Good? Questions? And this one was, I think, the question that most of you got right as well. So remember that hexane, it has like 6 carbons, right? C6H14. And then methoxy is like methyl that is attached to an oxygen. So what you do, you write 1, 2, 3, 4, 5, 6. Carbon number 2 is attached to methoxy, and that would be your structure. I think the most common error was that the students, some of you had like this methoxy attached here. So that won't be 2-methoxy hexane. And for your previous extra credit, I wrote the right answer for all of you, but for this one, I just referred you to the lecture to be, faster grading. So make sure to, have your answers corrected based on what I wrote here. Any questions? Are we good naming these different compounds? So can anyone tell me what was a mercaptan? SH. What is the other name of them? Mercaptans? Thiols, right? So if you have like SH attached to something, maybe I change the color. So that would be thiol. What about OH? What is that? What group of compounds they are? Alcohol, exactly. Okay. So as I said, we didn't cover much, but you need to kind of go back and review these things for your exam. And this is something, extra that I wrote here to make sure that you know the difference between alcohols, thiols, and all that. Okay, so if I asked you to name this compound, as I always recommend, write the expanded structural formula so you know what is happening. So you have CH3 that is attached to CH2, and then CH, right? And then CH2. So you have like CH2 here. So here you know that this OCH3 is a branch. And then CH2, CH2, OH. So if you want to name this compound, we care more about the OH. So we start, naming it from where it's closer to OH. And also, if you look at it, going right to left or left to right, we encounter the branch sooner too. So anyway that you talk, anyhow that you look at this structure, we start naming the carbons from here. 1 that is attached to OH. Does that make sense? So 1, 2, 3, 4, 5, 6. So what is OCH3? Methoxy, right? So how we name that? So first of all, what is the, so if we didn't have methoxy, right? What was the name of the compound? Hexanol, right? Remember? And then here, the carbon number 4, we have a methoxy attached to it, so we call that 4-methoxyhexanol. Okay? If you write 4-methoxy, 1-hexanol, that won't be wrong either. So, as I said, most of these compounds, there are like several ways to name them. Does that make sense? Are we good? Now naming a compound that has alcohol and ether. Okay. Now I can progress with our lecture. So those were kind of like review, but I saw the need to go through the problems in the class based on the responses that I got. So remember hydrogen bonding? So when did we have hydrogen bonding?
When a hydrogen forms a bond with something that's connected to nitrogen or fluorine or oxygen.
Yes, exactly. Nitrogen, oxygen, fluorine is if it attaches to a hydrogen, right? We can have hydrogen bonding. So if we look at these compounds, 1-butanol, diethyl ether, and pentane. And if you write the structures, and I expect you all to be able to write this, and I asked you this in the exam, which of the following is diethyl ether? Or like which one is 1-butanol, okay? So when you draw the structures, as you see here, which one of them can have hydrogen bonding? So this is the thing that I mentioned before, that you should have this oxygen that is, so your hydrogen should be attached to oxygen or fluorine or nitrogen. So here, the second one, you have, CH3, CH2, O, CH2, CH3. So here, your oxygen is not attached to hydrogen, okay? And in the few next slides, I'll tell you that if you have like butanol and diethyl ether, you might have hydrogen. You can have hydrogen bonding in between them, and I'll go through that momentarily. But just between diethyl ether, we cannot have hydrogen bonding because you need to have an oxygen that is attached to hydrogen. Does that make sense? So we have dipole-type, dipole-dipole interactions or intermolecular force between diethyl ether. Okay. And if we look at the boiling points of these compounds, as you see, 1-butanol has much higher boiling point compared to the other two because it has hydrogen bonding. But for the other two, the boiling points are fairly similar. And the reason is that molecular mass of, if you have just like oxygen and then look at its molecular mass is like 16, AMU, I guess, or, at least molar mass is 16 grams per mole, depending on how you look at it. But CH2, it would be 12.01 plus 2.02, or like 1.01 multiplied by 2, right? If we look at the periodic table and then calculate their masses, right? 14.03 AMU. So these numbers are fairly similar. So their masses is kind of similar. And also, when we talked about dipole moments in chapter 2, I told you that when the structure has symmetry, maybe the dipole moment, it won't be that strong. Remember, like CO2, that we said, although we have covalent bonds that are polar between carbons and oxygen, but in general, molecule is non-polar, okay? So we don't consider diethyl ether to be non-polar, it's still polar, but in general, it doesn't have much a strong dipole between its molecules. Does that make sense? Because of the symmetry that it has. So what I need you to know is that diethyl ether and pentane, they have similar boiling points because of the reasons that I just mentioned. Questions? Is that clear? And when we want to talk about water solubility, remember that like dissolves like. So if you have one butanol and you want to dissolve it in water, it dissolves well because of hydrogen bonding, right? They have similar intermolecular force. And also the same thing with diethyl ether, because you have like dipole, and then water has dipole, they kind of like dissolve well. But here, pentane and water, they're not similar. They don't have the same intermolecular force. What type of intermolecular force pentane has? Anyone remember? Covalent is between, intramolecular, right? It's just between them. But between
Is it just dipole?
van der Waals, right? London dispersion or van der Waals. Remember? But this is, pentane is like van der Waals or London dispersion. Question? Okay, so let's go through this example real quick. Write a structure for each of the following isomers and arrange them in order of decreasing boiling point. 3-methoxy, 1-propanol, 1 and 2-dimethoxy, ethane, and 1 and 4-butane-diol. So I'm just gonna write boiling point at the question for you. So I already did because I knew we were running out of time. So remember, you have propanol. First, write propanol and then add methoxy to it. So you have 1, 2, 3 carbons. And some of you confuse propane with pentane, 3 versus 5 carbons. Make sure to know that, right? And then you write that 1, 2, 3. So carbon number 1 is attaches to alcohol, right? And carbon number 3 is attached to an methoxy, right? Is that clear how to write this? And then here, 1 and 2 dimethoxy ethane or ethane. So we have like 2 carbons in the main chain, and then you have 2 methoxy. Methoxy is OCH3, right? And then you have 2 of that, which is attached to your both carbons. And the reason, again, we write 1 and 2 is that you can attach both of them to 1, right? So we specify both of them are attached to these carbons. Is that clear how to write that one? Is it? Okay. And finally, butane. So we have butane here. And like before, do you remember we had like alkadiene, alkatrine, right? Alkatrine or like those things. So here, if you have di, it means that you have 2 of ol, and ol is your OH. So now you should have 2 OH groups, right? Which are attached to your carbon number 1 and 4. Okay, are we good drawing these structures? Are we? So now if I ask you which one has the highest boiling point? Was that? Yes. Which one has the highest boiling point? Yes, the one that has more hydrogen bonding between them, right? And what is the next one? Or which one has the lowest boiling point?
The second.
the second, right? So this one has the lowest boiling point, this one has the highest boiling point, and if you want to arrange them based on increasing or decreasing boiling point, would be like this. Any questions? Okay. And just feel free to come and pick up your, maybe I can just do this.